Hi everyone. In this class, let me discuss the definition of subsequence and some theorems on that and some examples. Okay. So definition of this is, so as usual. So in lower level classes you have seen the meaning of set, okay, and subset. In the similar manner, we are going to define your sequence and subsequence also. So your subsequence meaning is, let n be a given sequence. Here, if nk is strictly increasing sequence of natural numbers, that is n1 is less than, n2 is less than, so on, then ank is called a subsequence of an. Then ank is called a subsequence of an. So here sequence an is given. Okay, in that we have to find a subsequence. Okay, a subsequence. Okay, so here example is given, that is the sequence. Here I take an example, that is the sequence as main sequence as n. So for that I am going to write the sequences 2, 4, 6, 1, 3, 5, so on, infinity, 1, 4, 9, 16, so on, infinity. This is even natural number set. This is odd natural number set. This is n square, that is of the form squaring numbers, that is 1 square, 2 square, 3 square, like that. So are all subsequence of the sequence n. So because your natural number set is bigger number set, so for that set we can set subsets as 2, 4, 6, 1, 3, 5, 1, 4, 9, 16. These all the values contains your natural number set. Therefore, the sequences 2, 4, 6, 1, 3, 5, so on infinity, and 1, 4, 9, so on infinity are all subsequence of the sequence n. So here I am going to define, we are going to discuss a theorem, that is, if a sequence n converges to L, then what about its subsequence also converges to L? So this is the question arises in one's mind. So therefore, for that, a theorem is there, that is, if a sequence converges to L, then every subsequence of n also converges to the same value. Here a sequence, if a sequence n converges to L, then every subsequence of an also converges to L. So here I am taking ank as a subsequence of the sequence an. Since an is converges to L, therefore given epsilon greater than 0, there exists a positive integer m such that n minus L is less than epsilon for all n greater than or equal to m. Using the definition of your convergent sequence, I am writing this of the form like this. So we can find a natural number nk naught greater than or equal to m. So therefore, if your nk is greater than or equal to nk naught, then nk is greater than m, because your n is greater than or equal to m. Okay, so from equation 1 we can say, because this is your nk your nk is greater than nk naught, so therefore we can say from equation 1 we have ank minus L less than modulus of ank minus L is also less than epsilon. So here we are taking ank is a subsequence of an, and then your sequence an converges to L. So using the definition we are writing this. So after that we can find a natural number nk naught is greater than or equal to m. If your nk is greater than or equal to nk naught, from equation 1 we are writing ank minus L is also less than epsilon. Therefore ank also converges to your value L, using the definition of your convergent sequence. Okay, so the converse of the above theorem is not true, because if every subsequence also converges to, subsequences converges to some value, then is the main sequence also converges to the same value? It is not true, because the converse of the above theorem is not true, because if infinitely many subsequences of a given sequence converges to the original sequence, converges, then the original sequence may not be converges. Because an example is there, that is an is equal to minus 1 to the power n. So here a to n converges, a to n minus 1 also converges. So that is the sequence an does not converge. However, the two subsequences, that is a to n minus 1 and a to n converges to minus 1 and 1, because a to n minus 1, when your n is odd, this becomes minus 1, when your n is even, you get 1. So means your a to n minus 1, sequence a to n minus 1 converges to minus 1, and a sequence a to n converges to 1. But your conversion means the main sequence, that is an is equal to minus 1 to the power n, does not converges, because it has to converge a one value, but here both means different value we are getting. So because of that reason, we can't say sequence an converges to minus 1 to the power does not converge. Okay, it is not a convergent sequence, that is n is equal to minus 1 to the power n. So next, let me see a theorem, that is a subsequences a to n minus 1 and a to n of a sequence n converges to the same limit L, then the sequence n converges to the same limit L, same limit L. So for this proof, let epsilon greater than 0 be given. A to n minus 1 converges to L, because already given this in the statement. So using the definition, we can say for epsilon greater than 0, there exists a positive integer m1 such that a to n minus L is less than epsilon for all n greater than equal to m1. Using the definition of convergent, we can say a to n minus 1 minus L, a to n modulus of a to n minus 1 minus L is less than epsilon for all n greater than equal to m1. So again we are writing here, so that is again a to n also converges to L. So using the definition of convergent sequence, we can say for epsilon greater than 0, there exists a positive integer m2 such that a to n minus L is less than epsilon for all n greater than equal to m2. So let m is equal to here I am taking m is equal to maximum of m1 and m2. Then a to n minus 1 minus L less than epsilon and a to n minus L less than epsilon for all n greater than equal to m. So therefore here we can say modulus of n, because this is a to n minus 1 and a to n are subsequences of the sequence main sequence an. Therefore the sequence an minus L less than epsilon for all n greater than equal to m. Therefore the sequence an converges to L. So if the subsequences converges to the same limit converges to L, and also your sequence an converges to L, then we can say means the subsequences converges to the same limit L, then we can say the main sequence also converges to the same limit. So example for this, test the convergence of the sequence whose nth term is xn is equal to 1 plus minus 1 to the power n. So here our given data is xn is equal to 1 plus minus 1 to the power n. So if I take x up to n is equal to 1 plus minus 1 to the power 2n. So as limit n tends to infinity, x up to n is equal to limit n tends to infinity 1 plus minus 1 to the power 2n. So this is equal to, because this, when your n is equal to 1, it will become even to for all the natural numbers, your power becomes even. So therefore it will become 1 plus 1. So this is a constant number, therefore here we get limit n tends to infinity x up to n as 2. Therefore sequence x up to n converges to 2. X up to n converges to 2. And x up to n minus 1 as 1 plus minus 1 to the power 2n minus 1. So limit, if I take limit n tends to infinity x up to n minus 1, this is equal to limit n tends to infinity 1 plus minus 1 to the power 2n minus 1. So when your n is, if I put any natural number, it will become minus 1. Therefore limit n tends to infinity 1 plus minus 1. Therefore this is equal to 0. Therefore the sequence x up to n minus 1 converges to 0. Therefore sequence x up to n and x up to n minus 1 are convergent to different limits. Those are 0 and 2. Therefore x of n is not convergent, because here your subsequences has different limits. Therefore the main sequence is not convergent. If your subsequences have the same limit, then your xn is convergent. So using this, you try to solve these two examples. Here I have given the hints. So test the convergence of the sequence xn is equal to n plus minus 1 to the power n divided by n. When your n is even, so 2n plus 1 minus 1 to the power 2n. So apply the limit for these two values, then you get some answer. So if your x up to n sequence x up to n and x up to n minus 1 have the same limit, then your given sequence is convergent. If x up to n and x up to n minus have different limits, then this is divergent. So test the convergence of the sequence xn is equal to minus 1 to the power n minus 1 divided by n. So x up to n is equal to minus 1 to the power 2n divided by 2n. So this is equal to 1 divided by 2n, and x up to n minus 1 is equal to minus 1 to the power 2n minus 1 divided by 2n minus 1. So this is equal to minus 1 divided by 2n minus 1. So apply the limit, then you get some solution. So if your x up to n and x up to n minus have the same limit, then the sequence xn converges to some value. If your x up to n and x up to n minus have convergent and have different limits, then your xn is not convergent. With this I conclude this class also. So if you have any doubts regarding your subsequences, you can ask questions, or you can send your questions to my WhatsApp number, so I can solve your problem. Okay, so thank you. With this I conclude this class. Thank you one and all.